Assalamualaikum warahmatullahi wabarakatuh. My name is Rizkia Rahmanita. I'd like to present my final project with the title is Design and Implementation with Guide-Slot Antenna for Landslide Detection Radar on X-band Frequency. My research purpose is to create with Guide-Slot Antenna for Landslide Detection Radar on X-band Frequency. Natural disasters in Indonesia, which often take many lives, one of them, landslides. Making a landslide detection radar system focus on one of the crucial components of radar is the antenna. As an early warning system to the community if there is a land movement that causes landslides so as to reduce fatalities. So, from that reason, my final project is made. The problem limitation of this final project is, first, the design, simulation, and implementation are only done for with Guide-Slot antenna, not integrated with radar system. Second, simulate and implement the antenna to produce specification that match the radar system for landslide detection. Third, measure the working frequency, return loss, VSWR, polarization, gain, and radiation pattern on the waveguide-slot antenna. This picture is illustration of a landslide detection radar system. The reflector will detect if there is a ground movement on the slope by emitting reflected waves. The reflected wave is received and forwarded to the data and signal processing on the signal processor, then displayed on the monitor. Then the ground movement that occurred will be detected before landslide disaster occurs. To detect a landslide radar is needed that can cover a large area and have an antenna with a large enough gain. Waveguide-slot antenna can cover a large area and produce a large enough gain. Therefore, I use a waveguide-slot antenna for a landslide detection radar. Radar has three components: transmitter, antenna, and receiver. Transmitter functions to emit electromagnetic waves. Antenna functions to emit electromagnetic waves towards the target. After hitting the target will provide a reflected wave and is reflected by the receiver. Receiver function as a signal filter or electromagnetic wave that is received to match what is desired by the strengthening the power, and then forward to the processing of data and signal in the signal processor and displayed on the monitor, so that it can be known if there is a shift in the ground causing landslide. Antenna specifications are needed before designing. The required specifications are frequency, return loss, VSWR, bandwidth, radiation pattern, polarization, gain, and number of slots. Then, simulate the antenna design in the software. If the result do not match with the specification, it must be optimized or iterated first. Then, the antenna can be fabricated. This picture is standard rectangular waveguide data. The frequency used in the design of waveguide-slot antenna is 10 GHz. The type used is WR90 with the dimensions 22.86 times 10.16 mm. The recommended frequency range is 8.20 GHz until 12.4 GHz. Antenna calculation result can be known for slot length and slot width is 15 mm and 1.9 mm. The distance between the two slots facing each other is 90.8 mm and the distance after two slots to the next slots is 9.9 mm and the last gain value is 7.2 dB. An expected result is creating an antenna that complies with landslide radar specification. And this is my reference for my final project.